Is it now displaying?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Kita
Yes,
na.
sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So right now you are seeing the data file, our old data file, which we have been using this ever since we discussed the parametric analysis this time. Okay. So this afternoon we will be dealing with the means or the comparing of means for the different variables, but specifically we will be dealing with the variable English proficiency. Okay. So we will be answering now the question, what is or what are the means of English proficiency according to sex or across sex. So we will be knowing now the English proficiency mean of the male and the female categories under the sex. So we will be knowing now the mean of the English proficiency of the male and the female. Okay? Nung nagdagda pa palo pa man, Daida. Paki na lang, mute na lang sa mga kanda, mga
Mic. Mga mic.
microphone. Mga mic ninyo, na lang. Mute. Para wala sang may guwa ng mga sounds. Okay. So we will be answering the question, what are the means of the English proficiency according to sex? So we are going now to know what is English proficiency mean of the male, and at the same time the English proficiency, the mean of the English proficiency of the female. Okay. So again, we are going to go to analyze. So from the analyze, we go to compare means. From the compare means, we will have to click means. Okay, you click now the means. So once you have clicked the means, you will be shown now the dialog box for the means. So for the dependent list, we are going to transfer English proficiency. That is our dependent list. And then for our independent list, we will be transferring sex. So from the variables, we will be transferring the English proficiency to the dependent list, and we're going to transfer now sex to the independent list. And then you just click OK. So from the table, you will now have the means of the male and the female group and their corresponding number of respondents, and of course the standard deviation. So the mean of the English proficiency in the male group is 84.875, and the English proficiency mean of the female is 85.5714, and then of course with the corresponding frequency. Actually, we have done this in our test. You have this particular table showing the mean for the English proficiency of both the male and the female. So again, from the mean, we can now conclude that the female got higher mean English proficiency, so the male or the female is better in terms of English proficiency. While for the consistency of English proficiency, it also belonged to the female group because they also got the lower standard deviation, which is 5.68 and something. So this is the English proficiency means of the male and the female. Now, how do we get the means of the English proficiency according now to the grade level? This is also shown during our discussion under the ANOVA. So from here, we will go now to analyze again. Then we will have compare means again. Then we will have means. And the dependent list will still be English proficiency. But this time, we transfer sex, and in lieu of sex, we will have the grade level. We transfer now grade level to the right side, to the independent list, and we just transfer sex back to the variable space. So we click OK. So from here, it is shown that the mean for grade 7 is 85 point something, 8750. For grade 8, 85.8750. For grade 9, 87 flat. And for grade 10, 84.1429. With their corresponding number of respondents. And then, of course, the standard deviation. So from the mean, we can now conclude that grade 9 performed or they got the better English proficiency because they have 87 as their mean. And for the consistency of their English proficiency, grade 8 got the lowest standard deviation. So grade 8 is the more consistent group in terms of their English proficiency. So this is now our English proficiency in terms of sex and English proficiency in terms of grade level. Okay, so another question. Let's say if you want to know the mean of the English proficiency of sex and grade level combined. So we will be determining now the mean of the English proficiency of the male of the grade 7, the male of the grade 8, the male of the grade 9 and 10, and of course for the female of grade 7, 8, 9, and 10. So we are computing now for the English proficiency means of the different grade levels and between male and female. So we go now to analyze. Then we have compare means again. So still, our dependent list would be English proficiency. That is our dependent variable. And this time, the grade level you just click next. And then again, you highlight sex and then transfer it to independent list. And then next also. Okay. Then you just okay. So you will have this one. So grade 7. So since our grade 7 is purely male, so we have the mean of the English proficiency of the grade 7, which is completely female, a male, is 83.8750. And the corresponding deviation, standard deviation of 7.58649 for 1. And then for grade 8, also all male, 85.8750. For the grade 9, also all female, 87. For grade 10, all female, 84.1429. So this is now the combination of grade level and sex. Means of the English proficiency across sex and at the same time across grade levels. So that is our table for the combined sex and grade level for English proficiency. Okay. So do you have any questions so far?
Answer.
Question? Okay.
None,
Yes,
sir.
sir. What, sir?
Okay. So we will now go to non-parametric analysis. Take note that last time we have the parametric analysis comprising of the t-test for independent samples, t-test for dependent samples or paired t-test, and then we have the one-way analysis of variance, and of course at the same time the relationship coefficient of the person R. This time we will have the non-parametric. Take note that in the non-parametric, we are already assuming that the distribution of the data is not normal. Meaning to say, the distribution of the data is not assuming normality, or it is not comparable to the normal curve. So we can now make use of non-parametric analysis. So the non-parametric analysis, these are actually counterpart of the parametric. For example, in the parametric analysis, we have the t-test for independent samples. T-test for independent samples. The counterpart of the t-test for independent samples in the non-parametric analysis is the Mann-Whitney U statistic. The Mann-Whitney U statistic. That is the counterpart of the t-test for independent samples. Now, for the t-test for dependent samples or the paired t-test, the counterpart in the non-parametric analysis is what we call the Wilcoxon signed ranks test. The Wilcoxon signed ranks test. That is the counterpart of the paired t-test. For the one-way analysis of variance, the counterpart in the non-parametric analysis of the one-way analysis of variance is the Kruskal-Wallis H statistic. The Kruskal-Wallis H statistic. And the counterpart of person R in the non-parametric analysis is the Spearman rho. Spearman rho. So we are going to take up this 4 non-parametric analysis, which are the counterparts of the parametric analysis. Okay, so we go first to the Mann-Whitney Q statistics. Before that, let us go back to our data. If the data now, since we have 30, when your data is less than 30, we can now assume that our distribution of the data is not normal. So if it is not normal, it simply means that we can now go to use non-parametric analysis. Okay, assuming that our data is less than 30 respondents. Take note that our data is 30, no? But let us assume that it is less than 30 so that we can make use of the non-parametric. Okay, so in the non-parametric analysis, we will have first the Mann-Whitney. So the question for the Mann-Whitney is there a significant difference, just like in our former example in the parametric analysis? So is there a significant difference in English proficiency of the respondents according to sex? Okay, so that is the statement of the problem. So in order to solve for this, assuming that the data is less than 30, so if it is less than 30, we can go non-parametric analysis. But if it is greater than or 30 and more, we can go parametric analysis. But assuming that our data is less than 30, so meaning if it is less than 30, then we can assume non-normality, so we can have the non-parametric analysis. So in the non-parametric analysis, since we are talking of sex, and sex is categorized as male and female, so therefore it has 2 categories. So if it has 2 categories, then we can have a test. So the independent test, the counterpart of that in the non-parametric is the Mann-Whitney. So to have the non-Whitney analysis or H statistics or the U statistics, by the way, is to have the analyze again. From the analyze, we go down to the non-parametric test. Non-parametric test. So in the non-parametric test, we will now go to two independent samples. So since there are two independent samples, the male and the female. So we click now two independent samples. And then we go to the test variable list. The test variable list is, of course, the English proficiency. And the sex is in the grouping variable. And in you also have to click on define groups. Again, group 1 is group 1 for the male, and group 2 is group 2 for the female. So you continue. Take note that in the test type, here in the test type, the default is the Mann-Whitney U. That is the Mann-Whitney U statistic. So since it is already checked because it is the default test, then all you have to do is to click OK. So from the Mann-Whitney test, you will have now the Mann-Whitney U, which is 102.5. And the asymmetric significance is 0.692. That is the 0.692. Actually, this one is the asymptotic significance because our distribution is not normal. So we are going now to compare again 0.692 to our level of significance of 0.05. So again, 0.692 is greater than 0.05. Therefore, it is not significant. So it is not significant. So meaning to say that the English proficiency of the male and the female are just the same because there is no significant difference. So if there is no significant difference, it is just like thing. Okay? Question? Okay, I assume that you are following. Okay, so the next test, which is of course the counterpart of the paired t-test or independent samples t-test, which is the Wilcoxon signed ranks test. So again, we are assuming that our data is less than 30. Okay, assuming that our data is less than 30. So again, we go now to our state of the problem. The state problem is there a significant difference in English proficiency of students or respondents according to grade? No. This is now for the no. This is now, and that is for the ANOVA. The statement for the paired t-test is, by the way, this one. Is there a significant difference between the English proficiency and academic performance of the respondents? So we're now comparing now the English proficiency and the academic performance. So take note, this time you have also two groups, but that is composed only of one individual. One individual performed the English proficiency and the academic performance. While in the Man Whitney is, we have two individuals considering only one variable, and that is English proficiency and categorized as male and female. These are two distinct individuals. Okay, so is there a significant difference between the English proficiency and academic performance of the respondents? So we go now to analyze. Go back again to non-parametric test. And this time we go to K independent samples. Sorry. We have now two related samples. Two related samples. Because we are still dealing with the Wilcoxon. So two related samples, we click that. And we are going now to pair the English proficiency and the academic performance, just like your paired t-test. And this time, the default test is the Wilcoxon. The default test is the Wilcoxon signed ranks test. So all you have to do now is to click OK. Okay. So we have now the z-test. That is the Wilcoxon test, which is negative 0.093. And then the asymptotic significance is 0.96, 0.926, 0.926, and that is still greater than 0.05. So if it is greater than 0.05, not significant. So again, this only confirms the results we have last time in our paired t-test. Okay, so that is now for the Wilcoxon signed ranks test. Now for the Kruskal-Wallis. Kruskal-Wallis is the equivalent test for the non-parametric, which is ANOVA. So the counterpart of ANOVA is the Kruskal-Wallis. So in the Kruskal-Wallis, again, we have several groups and one variable. Several groups or categories comprising your one variable. So again, we have analyze. We go now to the non-parametric. So this time we have the K independent samples. So this is now K independent samples. Okay, so we have now our English proficiency for the test variable, and this time the grade level. And by the way, the problem statement for the Kruskal-Wallis is there a significant difference in English proficiency of the respondents according to grade levels? That is the statement of the problem for the Kruskal-Wallis. So if you're going to look into the test type is defaulted at Kruskal-Wallis 8 statistic. So this is our Kruskal-Wallis. But before we go to OK, let us first define our range. So you click define range, and we have the minimum is 1, which is representing grade 7, and the minimum and the maximum, by the way, is 4, representing now grade 10. So the minimum is 1, which is representing grade 7, and the maximum is 4, representing grade 10. So we continue. So we'll just click OK. So you have now the Kruskal-Wallis. Kruskal-Wallis is the asymmetric or the asymptotic significance is 0.672. 0.672. Again, that is greater than 0.05. So if it is greater than 0.05, it is not significant. Okay. Next, the Spearman rho. Yes. Okay na? 9. 9 to 12. Okay. Tapos na naman, ano, sa testing mo, ang video ng isend mo sa ako, isend mo sa ako ng iyong output. Kailangan na output na kita sa SPSS. Ang output mo lang ito. Okay. Isend mo lang na sa ako. Okay. Okay. Bye. Okay. So we go now to the Spearman rho. So this time we will have now the statement, problem statement, is there a significant relationship between English proficiency and academic performance? So to answer this question, we will have to go to analyze. We will have correlate and then bivariate. So we are going to transfer English proficiency and academic performance. So from here, we uncheck person and check Spearman from the correlation coefficient. So all we have to do is to just click OK. So from here, the correlation coefficient or the Spearman rho is negative 0.163. This is again very weak. And we have a negative correlation, which is inverse correlation, meaning to say, when proficiency increases, academic performance decreases. And when you have the significance value, 0.388, this is again greater than 0.05. So this is not significant. So meaning the direction is inverse, the degree is very weak, and there is no significant relationship. So that is the interpretation for the Spearman rule, just like your person R. Okay?